Hello everyone. Today we're going to be continuing our discussion of multiplying polynomials, but today we're going to be looking at some special cases of those. So for this first video, we're going to be looking at square of a binomial pattern. So you may get a question where it looks more like this, where you have just one binomial, but it's going to be squared, and either they're added in the middle or they're subtracted. And so basically what that means, when I have a plus b squared, if you remember what the exponent 2 means, that means I am multiplying the base by itself with itself twice. So a plus b quantity squared, that is the same thing as a plus b times a plus b. Just like x squared is equal to x times x. 3 squared, I take that base, it's just the same thing as 3 times 3. A minus b squared would be a minus b times a minus b. Common mistake we see a lot of times from students in algebra is they think that this is going to end up equaling a squared plus b squared. But that is not the case, so do not be that student that does that on the test. Those don't end up equaling each other. What we'll see in the first example is there is a whole nother term that ends up being in the middle there. So if you do it this way, you aren't going to get the right answer. You're going to be missing out on a whole term. So let's go ahead and see what I'm talking about there. So looking at this first example, I have 3x plus 4 quantity squared. So I know that's really just 3x plus 4 times itself. And so doing what we learned last time, I'm going to do my double distribution. So I'm going to distribute the 3x to the 3x plus 4 first. And then the 4. And then now I'm going to distribute this. So 3x times 3x, I get 9x squared. 3x times 4, I get 12x. 4 times 3x, I also get 12x. And then 4 times 4, I get 16. And then last up, I'm going to go ahead and combine my like terms, and that's going to be those middle ones. So I have 9x squared. 12x plus 12x, I get 24x plus 16. So I see with this perfect square example, square of a binomial, I will end up having this middle term. So if I did it this way, I miss out on that term right there. Okay, let's try another one. So now I have 5x minus 2 quantity squared. So the same thing as 5x minus 2 times 5x minus 2. And so I'm going to go ahead and do a shorter way than this way. I'm just going to skip this second step and go straight to multiplying. So when I do 5x times 5x, I get 25x squared. 5x times negative 2, I get negative 10x. Negative 2 times 5x, I get negative 10x. And then negative 2 times negative 2, I get plus 4. And then just combine my like terms. Negative 10x minus 10x, I get minus 20x plus 4. We'll look at one more example. So here I have 3 plus n quantity squared. So that's really just 3m plus n times 3m plus n. This one ends up looking a little bit different just because I have 2 variables, but it would be the same process. So doing the shorter way again, I'm going to do 3m times 3m. 3 times 3 is 9. M times m is m squared. 3m times n, I just put those variables together. since they're not the same base. N times 3n, I'm going to go ahead and write that as 3mn, just so it's matching that previous one. And then n times n, I get n squared. 3m plus 3mn, they have the same variables with the same power, so I can combine those to get 6mn plus n squared. So something you may notice with this pattern is that all of these in this middle here end up being the exact same number, and that will be the case every time with these problems.